Testing. All right, this is chapter 5, continuing on page 179. And on page 179, we're introducing the do while. The do while, we enter into the while loop with the keyword do within our main function. Do, and then we have our open and close braces. So we're going to initialize counter as a positive int and initialize it to 1. And then we output 1 and continue to output 2 blank spaces. So I have some spacing in my output. Counter is incremented with the plus plus counter, so it's now 2. The test occurs at the bottom of the loop while counter is less than or equal to 10, and 2 is less than or equal to 10, so I return to the top of the do and continue with the body of the loop another time, and output 2 and append 2 blank spaces, increment 2 by 1 with the plus plus counter, and then check while counter is less than or equal to 10. It is. So I repeat the loop again, go back to the matching do, continue with C out, we're going to output 3 with a couple of spaces. We'll increment. We'll test. Should the loop continue while counter is less than or equal to 10? It is. I'll return to the top of the matching do, beginning with output, some spacing, increment. While 5 is less than or equal to 10, it is. Go to the top of the matching do, output 5, some spacing, increment 5 to 6. 6 is less than or equal to 10, so I'll perform the body of the loop again and output 6. Counter is incremented to 7. Test, 7 is less than or equal to 10. So go to the top of the loop and output 7. I'll increment 7, 8. Test, 8 is less than or equal to 10. So I go back to the top of the loop and output 8. I increment 8 to 9. While 9 is less than or equal to 10, it is. I'll process the body of the matching do loop again and output 9. Increment counter by 1 to 10. Test while counter is less than or equal to 10. It is equal to 10, so I'll output 10. Counter is incremented to 11. I test do the while condition. Counter is less than or equal to 10. It's false, so I proceed with the next line number following the do while loop. I'll show you a visual of that UML on page 180. We're coming in and we're going to display the counter value with this C out, increment the counter, and then test the counter. As long as the counter tests less than or equal to 10, we continue to return to the top of the loop, process, increment the control variable, test the control variable, and continue to the top of the loop. When the condition of the while is false, we exit. On page 179, we have the discussion regarding the do while iteration and the while iteration. The do while iteration is similar to our while statement. In the while, the program tests the loop condition at the beginning of the loop before execution of the body's loop. So if the condition tests false, the body of the loop would never be executed. That's a special note. While iteration. While something is true, we'll process the body of the loop. If after priming your condition variable of the condition statement, and if the variable condition, the condition of the variable tests false, the while loop would never be executed. The do while, however, after executing the loop's body, the condition is tested. So in the do while iteration, the body always executes at least once. So please keep those distinguishing characteristics separate. Next, we're going to look at our switch selection statement. And the switch on page 185, UML model, we're able to select one of many options. Our if, you select the true portion if the condition is true. The if else, you select one of two. Select true if the condition is true and do the true path. Skip the else. If the condition of the if tests false, we do the else path and skip the true path. Now we're able to select one of many. So we have a case and we test that case. If it tests true, we process the body of that case and break. And break will take us all the way down to the statement immediately following this switch. We have another case, case B. If case B tests true, we'll process case B statements. And at the end of that block, we'll have a break statement which breaks us out to the end of the switch to continue with the next line of code. So we can have many cases. Each will be tested. If it tests false, you continue to the next. If it tests false, you continue to the next. If it tests false, you continue to the next. If a case is true, you complete that case action and break immediately out of the switch and follow with the statement immediately following the switch block. So our code example is on page 181. This is exercise. This is program on page 181. And we're going to be using the switch statement to count letter grades. Main begins and ends on line 74. We are declaring int variable total to be initialized to 0, and then we're initializing unsigned positive integers, grade counter, A count, B count, C count, D count, and F count to 0. So in initialization, we're initializing counters. accumulators, and totals. We're supposed to enter the integer grades in the range 0 to 100. Type the end of file indicator that terminates input. On Windows, type Control-C and then press Enter. So we're going to be continuing to input until the user taps Control-Z, indicate that they are done. While we're looking for the grade that the user inputs, we're going to allow total to be incremented by that grade, and we're going to increment the grade counter by 1 with a pre-increment operator. Looking at the switch, we have the keyword switch and a condition, grade divided by 10, through the AND switch on page 50, which includes each case along with a default case. The switch allows us to choose one of many options. So when we enter grade, they range from 0 to 100, and divide by 10, I'll get a case of 9. That means the grade was between 90. Case of 10 would be the grade is between 90 and 100 inclusive. So I want to count the A grades by incrementing a count. So I'll increment by 1 the count of the letter A grades and break out of this. Case 8, the grade is between 80 and 89. So if I type 85, divide by 10, I'll get an 8, integer division. So I'll increment the B and break. Be sure to remember to include the break statement for each case. Now, it's also possible for a case statement to include multiple statements. For case A, case B, we could have multiple statements. We use our break to indicate that there are multiple statements to be processed within this case option, and be sure then to include the break statement as well. And we have a default. Our grade is going to be incrementing either an A grade, B grade, C grade, D grade, or it will be increment the F grade. So we can use the default case. One of many will be selected. The default case is we're going to increment the F grade and break out of that case. And then we use cout to print a report. So I have started a new project. And will expect that you start a new project for this code on page 181 and 182 to test the execution of the case control structure. So an example might be enter the grades in the range 0 to 100 as a prompt to the user, and use your system terminate input with the system that you're working with. We're using Windows, so Control-Z is your simultaneous keystroke. So we enter 99, 92, 45, 57, 63, and so on. Control-Z to stop. Our grade report then prints the total of the 10 grades entered is with a counting accumulator in the total variable. The class average is a calculation of the sum of the total grades divided by the count entered. And then the number of students who receive each grade. Our A count is 4, the B count is 1, C count is 2, D count is 1, and the F count is 2. Be sure to read the corresponding line by line narration that follows the code. Well, then we're going to look at our logical operators. And the logical operators begin discussion on page 188. We need a logical operator to indicate the logical and the logical or. We're looking at an example of code if, in parentheses, we're going to test gender equal female and age is greater than or equal to 6. So we're going to check to see if the variable gender is equal to female. If it is, it returns a true. And we're going to test age is greater than 65. If it is, it returns a true. In order for the logical operator and to test true, we need a true and a true condition, which tests true, and we can process the increment of the number of senior females. So our coding is, we have two relational tests, one on either side of the operator indicating the logical and test. And the logical and test returns a true or a false. So if expression 1 is false and expression 2 is false, expression 1 and expression 2 returns false. Both expressions need to be true in order for expression 1 and expression 2 to return the logical and true. So if I have a false and a true test, it still returns false. Both expressions must test true. Expression 1 must be true and expression 2 must be true for the logical and operator to return true. And we have a case where expression 1 is true and expression 2 is true. So expression 1 and expression 2, expression 1 is true and expression 2 is true. So expression 1 and expression 2, the logical operator or and would return true. We look at our logical operator or, which is your vertical bars, and that's 2 vertical bars. On my keyboard, the vertical bar is a shift just above the enter key. The logical or will process the body or if either or both of the conditions are true. So we're testing and notice we have nested parentheses. So I'm going to test semester average greater than or equal to 90. If semester average is greater than or equal to 90 test true, I have a true test. Or if final exam is greater than or equal to 90, if that's, I have true or true. The or logical will return true. The or logical returns true if one or both are true. Our logical expressions then, if I have expression 1 and expression 2, expression 1 is false and expression 2 is false, the expression logical or will return false. But if expression 1 is false and expression 2 is true, expression 1 or expression 2 will return true because one or both expressions were true. If expression 1 is true and expression 2 is false, expression 1 or expression 2 returns true because the logical OR will return true if expression 1 or expression 2 are true. And we could have the case for expression 1 test true and expression 2 test true. Expression OR 1 or expression 2 will test true and return true because either expression 1 or expression 2 or both need to be true for the OR logical return true. And then our logical negation is the exclamation point. The exclamation point, logical negation, also called logical not, reverses the meaning of a condition. And it is a unary operator. That is, it has only one operand. So we might look at this sample. If I have parentheses, nested. If not, and then nested parentheses. I'm going to test, is grade equal to sentinel value? Is the grade equal to the sentinel value? Well, if that tests true, then not true would be false, and I would not execute the body of the if loop, if statement. If grade is equal to the sentinel value, then not true. If grade is equal to the sentinel value, that's true. Then not true, test false, so I don't process the actions of the if. If grade is not equal to sentinel value, that would return a false, and not false is true. So I would process the body of the loop, and the next grade is. Not reverses the meaning of the condition. So not true is false, and not false is true. So if we have an expression that is false, not false is true. And if I have an expression that tests true, not true would return false. Your shared data file is figure 5.18, and you can execute that and trace your code with respect to the logical operators. One kind of tricky piece within coding is to remember the precedence and order of our operators. And the logical not has a high precedence. Logical not has a high precedence over many operators, and particularly notice that the single exclamation point is a unary operator. It operates on one operand. And then kind of a summary of our control statements. We have our simple sequence, processes one statement after another until we're done. The if statement allows for single selection. If the condition tests true, it's going to process the body of the statement of the if true block. But if the condition of the statement tests false, we just simply continue on with the statement immediately following the if. The if else gives us a double selection option. We can select either the true path or the false path. We test, and if it tests true, we'll do the true actions. If it tests false, we'll do the false actions. Either way, we connect with the body of the spine of the program. Selection. We also have our switch statement. Remember that the breaks must be included, otherwise we'll flow right into the next case. With sequential processing, we need to make sure that we break to break out of this case. So with switch, we're able to select one of many options. We test. If the test is true, we do the case and break out of it and continue then until the end of the switch and begin with the next following statement. If the first case tests false, we test the next case. If it tests true, we process the statements of that case, break out of it, and continue processing immediately following the body of the switch. We can have multiple cases until we look at our last case. In the last case, if it tests true, we process, make sure we break out, and complete with the connection to the body of the spine, logical spine of the program immediately following the switch block. And then we have our default processing, and we will do that no matter what if it optionally is included in your code. Next, we have repetition, where the while statement allows us to flow into the while test. If it's true, we'll process the body of the loop, return, and test again. Return and test again, as long as it's true. Notice that we test first before we process the body of the loop. The do while, we process, and when we're done processing, we make an increment on the control variable and test it. If it's true, we return and continue processing. As long as the test of the while is true, we continue to process. But note that in the do while, you will do the processing at least once. We flow into the processing before we test. So you will process the body of the do while at least once with the trailing test. The while, we flow into the test first, and if that condition happened to be false, we just continue to flow with the next consecutive line number, and that body of the while loop could indeed never be processed. And initialization for our for repetition. We initialize the counter in the for statement. We test if it's true or false. If it's true, we process the body. Be sure to increment, make a change to that counter, return, and test again. If it's true, we'll continue with the body of the for statement and increment our counter so we can test it again. And at some point, it must test false so we can exit the repetition of the for. Good visuals on the logic of our control statements on page 195. Please return to D2L for all of your assignments, homework, and projects. I just want to point out in D2L that your program project assignment for this chapter is exercise 5.17 on page 207, and I have published the pseudocode for the solution to that program. So please follow the pseudocode as a model to design the logic and the order of execution for that program solution for chapter 5. Right, thank you very much.